This is section 6.5, day 2, part 1, using the Pythagorean theorem. This is the back of the 6.5 notes. You'll have part 1 and then part 2, and your checkpoint is at the end of part 2.
All right, so this is day 2 of our notes for section 6.5. This is the back of the notes. We're going to start here and we'll finish this for tonight. So our first vocabulary key idea is a blank is a set of 3 positive integers, a, b, and c, that satisfy a squared plus b squared equals c squared. And we talked about this, I think I brought this up in one class or another, but it's called a Pythagorean triple. So we're going to fill that in. It's called a Pythagorean, and I got to write it this way. A Pythagorean triple. So I think we talked about it. We talked about a 3, 4, 5 is the simplest of Pythagorean triples. And the reason why is if I use 3, 4, and 5 and I plug it into this equation, that 3 squared plus 4 squared equals 5 squared. And we're checking it first. So we're saying, we're going to figure it out. So 3 squared is 9 plus 4 squared is 16. Does it equal, there's that question mark, 25? And if you check correctly, 25 does equal 25. So that means 3, 4, 5 is a Pythagorean triple. There are 3 positive integers that satisfy the equation a squared plus b squared equals c squared and keeps the left side and the right side balanced. So we have something called the converse of the Pythagorean theorem. And it states if the equation a squared plus b squared equals c squared is true for the side lengths of the triangle, so we're stating in the beginning it's true, what can we say? We can then say that the triangle must be a right triangle. So now we're going to do the converse. They're going to give you 3 measurements, and they're going to ask you, do these 3 measurements make a right triangle? And you're going to use the Pythagorean theorem to check, to see if those numbers, those 3 positive integers, actually balance that out. So I'm giving you this case again. Remember, it's a right triangle if a squared plus b squared does equal c squared. One key thing to remember, when using the converse of the Pythagorean theorem, you need to make sure that you substitute the longest length they give you for the hypotenuse. You can't mess that up. The c, the longest side, because I said 3, 4, 5, the 5 has to be the c because it's the longest side. So it can't go in for any of the others. So that's the first thing you do is build your key. What's A, what's B, what's C? And C has to be the longest, or the longest side, or the largest number of your Pythagorean triple. So we're going to check to see if numbers are Pythagorean triples or not in the next section. But I just wanted to quickly say to you about the converse of the Pythagorean theorem. So it kind of switches it around. It's saying that a squared plus b squared does equal c squared, so does it mean it's a right triangle? Now you're going to be justifying if those 3 values actually form a right triangle.
There will be no checkpoint until the end of the day 2 part 2 video, so wait, look at both sections, and then you'll have 4 problems to do at the end.